4.2, page 3. It feels so weird talking to myself in this room. I mean, I'm pretending that you guys are here watching the video. But I just feel like people are walking by, or they're in classrooms next door and they're like, who's in there making all that racket? Because like no one's on campus, you know? Anyway, here we go though. Okay, page 3, 4.2. So we've talked about how you can find the best fit line and how you can use it to make predictions. But it should be noted that it's only appropriate to do that if there is in fact a linear correlation between x and y. If there's not a linear correlation between x and y, then it doesn't make sense to use a linear model to try to make predictions for y based on x. Okay, so you only use the best fit line if there's a linear correlation between the variables. And we talked about how to determine if there's a linear correlation between the variables in 4.1. Okay, so what I want you to do, or what I want to do now, is walk you through a couple examples where we kind of go through the whole thing. You know, first of all, determine if there's a linear correlation, and then second of all, if there is a linear correlation, then use it to make some kind of prediction, to find the best fit line and make some kind of prediction. Okay. Before I do, I just want to point out this fact here, right? So it says, when the correlation coefficient R indicates no linear relationship between the variables, when the correlation coefficient indicates no linear relationship, and the scatter diagram indicates no relation at all, then the best prediction that we can make for Y is just the sample mean. So we just take the sample mean of our Y values, and that's the best prediction that we can make if there's not a linear correlation. Okay, so I'll show you an example of this. Let's take a look at number 3. Okay, so it says an engineer wanted to determine how the weight of a car affects gas mileage. The following data represents the weights of various domestic cars and their miles per gallon in the city for the 2008 model year. Ooh, I need to update these notes. 2008. That was 12 years ago. Well, anyway. Okay, so here's the weight of the car. Here's the miles per gallon. All right, so a car that weighs 3,175 pounds got 22 miles per gallon. Anyway, we're asked to draw a scatter plot, find correlation coefficient, find the least squares regression equation, and so forth. Let's do all of that in StatCrunch, okay? Okay, so I'm going to come over here to StatCrunch. I'm not going to enter the names of the cars. I just need to enter the actual data, right? The actual numbers. And as long as I'm leaving them in order, the names of the cars that correspond to them don't really matter all that much. So I just need to put in the weight and the miles per gallon. Okay, I'm going to check to see if I got them in there correctly. Okay, I think that looks okay. So if you're looking at your notes, you know, we're supposed to find the scatter, or draw a scatter plot. We're supposed to find the linear correlation coefficient, and we're supposed to find the least squares regression equation. So rather than doing each one of those things individually, I'm just going to do them all at once by going to Stat, Regression, simple linear. We want to compare the weight and the miles per gallon. You don't have to change anything else. Just go ahead and hit compute. Whoops. No, that's not the one I want. There we go. Yep, okay, that's the one I want. Okay. So here we go. We've got our correlation coefficient here. That's pretty strong, right? That's pretty close to -1. So that represents kind of a strong negative correlation between the variables. There's my scatter plot. I kind of like it better in a smaller window. There's my scatter plot together with the best fit line. Okay, so I'm going to start to write these things down. So the scatter plot, right, we've already done. The correlation coefficient is negative, it's about negative 0.959. I'm going to write that down. Okay. Of course, to determine once and for all if there is a linear correlation, we need to compare this correlation coefficient to a critical value, right? To the critical value from the table that is in your 4.1 notes. So looking at the 4.1 notes, ooh, how many observations do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Sorry, let me do that again. Right, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our sample size is 10, right? So I'm going to use the critical value that corresponds to n equals 10. Okay, so there it is. So that's 6.32, or sorry, 0.632. Okay, 0.632. So for n equals 10, critical value is 0.632. And remember, you compare the absolute value of r to the critical value. The absolute value of r needs to be bigger than the critical value in order for you to conclude that a linear correlation exists. And in this case it is, right? The absolute value of r is going to be 0.959. That's bigger than the critical value of 0.632. So there's a linear correlation. So I might say something like this. Since 0.959 is greater than 0.632, it says determine the type and direction of the relationship. So the type is linear. There's a linear relation. The direction is negative, right? Because r was negative, right? So we would say there is a negative linear correlation between weight and miles per gallon. Oh, let me zoom out. I know, half of you are watching the video and you're like, zoom out, zoom out. You're yelling at the screen for me to zoom out. Anyway, there you go, zoomed out. Okay. Even though you have ears, right? And I said it verbally. You could listen and write down the things I'm saying. Anyway, but here it is. Part C says find the least squares regression equation. That was also in the output. So I'm going to take you back to StatCrunch again to show you again where you can see that. But remember, you can see the least squares regression equation in two different places. Okay. So taking you back to StatCrunch. Okay, one of the places where you can see the least squares regression equation is right here. Okay, miles per gallon is y, weight is x. So you would say y equals negative 0.007x plus 44.4, right, or something like that. All right, so I'm just rounding. That's one place you can see it. Another place you can see it is if you scroll over to where your scatter plot was and hover your cursor over the red line, then you see the equation for the line there as well. So you can say y equals negative 0.007x plus 44.4. Okay, so that's what I'm going to write down for part C in the notes. So I'm going to say y hat is approximately negative 0.007x plus 44.4. I guess to keep it consistent, we could round to the same number of decimal places on both of those numbers. So if I round to 3 decimal places on both numbers, we would say negative 0.007x plus 44.402. So that's probably a better answer. Okay, so that's that. And now part D says, use the regression equation to predict a car's miles per gallon if the car weighs 3,500 pounds. So remember, X represents the weight, right? So they're saying the car weighs 3,500 pounds. We're going to plug in 3,500 for X and then see what we get for Y. So we say, well, Y hat would be approximately negative 0.007 times 3,500 plus 44.402. So I'm punching that into my calculator. 44.402. And I get 19.902. So remember, Y represents the miles per gallon, right? So if your car weighs 3,500 pounds, then we would predict that it would get 19.9 miles per gallon. Okay. Okay, so it would get about, I mean, really you'd say 20, right? You'd probably say 20 miles per gallon. But I'm going to say it would get about 19.902 miles per gallon. Okay. So that's that. That's that process from beginning to end. Now this is an example of a situation where it's appropriate to use the least squares regression equation to make a prediction because there was in fact a linear correlation between the variables. But if there's not a linear correlation between the variables, then it does not make sense to use a least squares regression equation to make a prediction. And in that case, the best thing we can do is to just use the sample mean. So I'm going to give you an example of that on page 4. So let me start a new video for page 4, and we'll see an example there.